And we're off. Morning. Yeah, well, it's me. It's morning for me. I'm speaking in the present to the future while you are listening to the past in your present. Okay, guys, so this is one of those things I feel I have to cover with you for APES that you have an understanding because the chances are they're going to include some kind of graphs where you're going to have to interpret. But I think you need the background in order to understand what the graphs mean. That would make a little bit more sense. One of the things in chapter 17 is looking at risks, looking at hazards, and there's different kinds of hazards. But we're going to be focusing on chemical hazards here, okay? Which gets into things like toxicology and toxicity. Okay, when you hear the word toxic, you should be thinking this is a bad thing. And in fact, yeah, it is. Okay, so when we look at toxicology, we're looking at the study of harmful effects of chemicals on humans and other organisms. So you could look at it as the study of poisons, if you will. When we look at toxicity, we measure how harmful the substance is by the ability to cause the injury, the illness, or death to any living organism. So, factors that affect the harmful effects of a chemical. So, the basic idea about toxicity is anything, chemical, natural, or synthetic, can be harmful if you ingest, consume, whether it's through the skin, through the body openings, or you eat it, if it's ingested in a large enough amount. Case in point, there's a little bit of cyanide in every apple seed. Okay? If you're eating an apple and you swallow a seed, you're not going to be worried about the effects of the cyanide in that apple seed. Okay? If you were eating a truckload of apple seeds at the same time, then you have something to worry about. Okay? So that gets into this basic idea of toxicity, part two. What level of chemical ingested, taken in, inhaled, or absorbed through the skin causes harm? That's the question. So, how much does it take? Okay. So, I'm going to. So, then we have to talk about the idea of a dose. Okay. Not to be confused with the Spanish word dose, meaning two, and that's spelled DOS. Okay, dose is talking about how much of the chemical is taken in. It could be, in milligrams, could be grams. Okay, it could be in micrograms. It depends on the chemical. Okay, now the other side of the coin, when we look at chemical hazards, is the genetic makeup. How sensitive is the organism to the chemical? It could be more sensitive to more than one chemical. That's another thing to look at. Solubility, how easily can it go into or through the environment? Okay, so for example, if you have oil or fat soluble toxins, they can get they can penetrate cell membranes. That gets to be a problem for living things because if fat or oil soluble toxins get in, they really get in. Then we have to look at persistence. What's the substances resistant to breaking down? Okay, that's another thing to look at. Is it something that's quickly broken down, or is this something that's going to take a long time? Biological magnification, concentrations of toxin increase as they pass through successive trophic levels in a food chain or food web. Yeah, you should absolutely know that. Okay. So we can look at concentrations here, and I want to look on concentrations with you guys later on. Here, we'll talk about parts per million and things like that. Okay, I'm not going to worry about that. So, how do we measure the toxicity? How do we determine how toxic the substance is? The answer is to expose a population to measure doses of it. And that's where we get the LD50, the median lethal dose. There is something called a dose response curve, which is what they may be showing on the AP exam. And they're asking you to evaluate it. Okay. So the median lethal dose, or the LD50, it's derived from this dose response curve and represents the dose at which 50% of the test organisms, such as pests, are killed. So now we've got something here. At what point will half of the population be killed? Not messed up that they're still alive, but be dead, as in they're not doing anything anymore. Okay, so that's the LD50. So when we look at something like this, here's an example where we have a percent responding here, and then here we have a dose on a log scale. Doesn't matter the units. The important thing is that you guys understand when we are talking about what's the lethal dose for a chemical that it wipes out half the population. And this is it right here. So you have your dose here, and you find where your 50% population is here. And then, of course, this is where you're going to mark your LD50. It's that simple. It really, really is. Now, so you have the linear, okay, and then here's the, again, a response versus dose curve. Here's a linear, excuse me, and this is your threshold, all right? So there's a couple of kinds of lethal dose response curves. One is a threshold. It's a certain level of the toxin has to be reached before the effects begin to show. Now note that doesn't mean half the population's wiped out instantly. It just means at what point are we starting to see some of the stuff happening, okay? Um, there are different amounts of toxins that will affect different populations differently. So if we look at rats, for example, if I have toxin A and toxin B, if I give a milligram to the rat if I introduce a milligram into the drinking water or the rat population and they drink it and half of them die like that, that's a pretty low dose. That's pretty doggone quick. Okay. On the other hand, if I got toxin A and I add a milligram to the water, and out of 100 rats, 5 rats are dying, there's a threshold there. Okay. That means that, okay, we know that around a milligram, we're starting to see effects of this pressure, of this toxin. Okay. Now, the non-threshold is any dosage of the toxin will harm the organism, and that harm will increase as the dosage increases. So for some toxins, it doesn't matter how much you give, it's just deadly to start with. Other toxins, you need to build up the amount of toxin that you're getting before you something really bad happens to you. Okay. And at that point, I'm going to stop here for the lethal dose section.